Hello, welcome to another video of heuristic algorithms. In this video I'm going to demonstrate the nature of combinatorial problems, and also I'm going to take advantage of this combinatorial problem to show you what it means to have a greedy algorithm and a randomized algorithm. So let's consider this table. This table represents jobs. Each one of these rows represent a job, and actually this first column represent the position in the sequence that jobs are going to be entering to manufacturing site. The manufacturing site has two workstations, and all the jobs needs to enter to each one of the two stations in the same order. First station 1, then station 2. And we're going to have the alternative to change these jobs in different sequences to figure out which one is the most convenient to execute. So we're going to separate the position in the sequence in the first column. Let's skip for a moment this random number, and let's go to column 3 that depicts the job IV, and that's while the position for the first column is always going to be 1 through 15 in that order. The job ID is going to tell us if a particular job has changed its position. The following column is the due date measuring time units. This could be hours or this could be days. And the next position or the next column is the processing time in the first station, and those are 14 units of time. The next column is the processing time in the second station, and this is the data set that we have for all the 15 jobs. The rest of the table is calculated, and if we assume that the first position in the table is the first one to enter the system, that means that the first position in the table can enter the system right now at t equals 0. Since the processing time is 14 for the first station, it would leave the first station or the finishing time would be 14, and that means that work can go on to the next station at t equals 14. So the starting time at t equals at the second station is 14 units of time. And since the processing time is 9, then the finishing time for at the second station for this first job is 23 time units. Since the due date is 16, that means that the total lateness of this job is 7 units of time. The second job will start at first station once the first job has finished at that first station. So that means that the second job can start at t equals 14, and since the processing time is 11 units of time, all this is by the way stipulated in these formulas in Excel, so it's very easy to implement. The next station is going to be start exactly when the previous job finished, making the station available. And again, the processing time 1 is 11 units, the finishing time of the second job at first station 25 units. And then the next decision on when this job is going to start at the second station, we have to have both the second station available, and the product should have finished in the first station. So it's going to be the maximum of the two events, whether or the times at which the events happen, where this job has been released from the previous station, or this station, the station number 2, has been released from the task of processing the previous job number 1. So in this case, in this example, it happens that the station number 2 has to wait 2 units of time for the next job to arrive, and therefore the starting time for the second job is 25. The The finishing time is 37 because we have 12 units of processing time, and we can compute the lateness to be 18 since the due date is t equals 19. So the difference between 37 and 19 yields 18 units of time. And the rest of it is just a copy of those formulas. And intuitively, if we want to minimize some performance parameters, a couple of that we can think of is or to identify some performance measures. We would have the lateness of the job or the number of jobs late, and we want to minimize these two. A common sense algorithm in our head would be, well, let's sort these jobs based on the due date. So the first one that needs to come in would be the first one that is expected to by the customer earlier. And that's exactly what we've done if you check the column for the due dates. The jobs 1 through 15 were conveniently identified based on the sorting on their due date from the first one to the last one. The shortest due date or the closest due date is 16 units of time, and the farthest in time from now is the 15 with 137 units. And we would expect that this could be a pretty good solution. However, we wonder what would happen if we change these answers. To begin with, all the jobs would arrive late, and that's probably not the best, and we wonder if we could minimize somehow the number of jobs that are late, or at least if everything's going to be late, at least maybe minimize for the benefit of some customers the total lateness that we have in selecting this particular sequence of jobs within this job shop. And for that purpose, we can do this manually by generating a random number here and sorting all jobs based on that random number, and regenerate a random number. And every time we generate a new solution. However, that would be like running a lottery, in the sense that we are not learning from the previous experience. We just trying shuffling the cards in the deck, and while we are making an exploration of the solution space, the actual fact that we have a good solution is somehow lost because we're not tracking which way we want to go. Alternatively, we could develop a different algorithm in which maybe, as opposed to sorting all of these, we keep most of them and we just switch between two. For instance, the first job against the fourth, and if that is a better option, then we will keep it. But if it's not a better option, we get it back to their current position and we flip another pair. And that would be a randomized greedy algorithm. It's randomized, obviously, because we do not specifically select any of these two pairs. We can just simply choose randomly which of the two pairs are going to be flipped, one with the other, and then we measure if it's a benefit, and we will only proceed to keep that combination or that new sequence if the combination makes an improvement in terms of, say, for instance, the total lateness of the jobs. So that's exactly what we're going to do in the next video.